In this video, we are going to look at projectile motion. Without much further ado, let's get started. Right, in projectile motion, this is motion in 2 dimensions, where you have in the x direction as well as in the y direction. Now, in the x direction, there is constant speed. In other words, it is not affected by gravity. And in the y direction, it is affected by gravity. So, in this case here, let me just draw it the right way, where you have the vector going down. Okay, so the resultant motion will be that way. So the horizontal component is u cos theta, and the vertical component is u sin theta. The path is parabolic, and the force that acts is gravity, and we're going to consider in the absence of air resistance. The motion in the x direction is independent of the motion in the y direction. I've included these links for you to watch some animations. There's some animations on firing a cannonball as well as a motorcycle jumping a ramp. Okay, from a ramp rather. Then we have the equations of these parabolic motions. The horizontal velocity, like I said, remains the same because there's no air resistance acting. The vertical component changes because of gravity. So we're going to consider the equations of motion. V is equal to u plus at. In the horizontal, V is equal to u plus at. It's going to change because it's not affected by gravity. Our a is g, so it will be 0. So which means V is equal to u. That is in the x direction. So this is always equal u cos theta. Then in the y direction, we have V is equal to u plus at, which is Vy is equal to u sin theta plus gt. Okay, plus gt like that. So this one is affected by gravity. And then the resultant vector V is found by Pythagoras. The angle is also found using trigonometry, where you say tan theta is equal to opposite of adjacent. The opposite is the y, and then the adjacent will be the v at the vx. Okay. V squared is equal to u squared plus 2as changes to be u squared sine squared theta plus 2gs. Now for motion to the maximum height, at the maximum height right there, the vertical velocity is 0, but then the horizontal component is still there. So the resultant at the maximum height is equal to u cos theta. Okay. So which means the vertical component of the velocity decreases until you reach to the maximum height. And then after the maximum height, it starts to increase again. Then when it strikes the ground, you find that the initial velocity is now equal to the final velocity. That is in the absence of air resistance. So at the maximum height, V is equal to 0. We are now saying 0 is equal to u squared sine squared theta minus gs. Taking vectors going up is positive, down is negative. So S will be equal to u squared sine squared theta over 2g. Then the time taken to reach the maximum height, to use V is equal to u plus at. Working with the vertical component. So at the maximum height, we said V is equal to 0. So we have u sin theta minus gt. Making t the subject gives you u sin theta over g. Now to get the total time of flight, it's going to be times 2. Remember, it's a symmetrical parabolic shape. So what we have here is the same as what we have over there. So it will be 2u sin theta over g. Then the range, we have the range which is the total distance from the time of launch to the time when it strikes the target. So that will be the range that is in the horizontal, so which means it's going to be speed times time, because the speed is constant. So it's u cos theta times time to get the range. But now, since you know that the range, we know the time is 2u sine theta over g, we can substitute it over there, and then it comes to be 2u squared cos theta sine theta over g. Now, sine 2 theta, this is an identity in mathematics, it is known. So sine 2 theta is equal to 2 sine theta cos theta. So splitting this one, what we got there, we get u squared times 2 cos theta sine theta. Okay, so which means this is the identity sine 2 theta, so it becomes u squared sine 2 theta, which is what you see over here, divided by g. Now, the highest or the maximum value of sine theta is 1. That's the maximum of sine theta, the maximum value. So, which means sine 2, so 2 theta will be equal to 90. So this case, theta will be equal to 90 for the maximum value of sine theta. So, which means theta, in this case here, will be equal to 90 over 2, which is 45 degrees. So for a maximum range, the angle of launch is supposed to be 45 degrees. So for a particular projectile or particular initial speed, the maximum range that is possible there will be at 45 degrees. And your range will be having a value of u squared over g. Right, so let's do this question, and then we end our video. So the question reads, a cricket ball is thrown with a velocity of 30 meters per second at an angle of 42 degrees to the horizontal. Find the time taken to reach the maximum height. So remember, I said at the maximum height, v is equal to 0. So using v is equal to u plus at, our acceleration is g, so it becomes minus there. So it's u minus gt. So v here is equal to 0 again, so u is equal to gt. So t will be equal to u over g. And this is in the y direction. So this is u sine theta. Our u is 30, sine 42 over 9.8. So this should give you the value there, 2.05 seconds. And then moving on to the next one, it says total time to retake for the flight. Total time of flight, you multiply by 2. Remember, we said to the maximum height, you multiply by 2 to get the total time of flight. So it is 4.1 seconds. And then the maximum height reached, you use v squared is equal to u squared plus 2as. Okay, so v is 0 at the maximum height, so which means s will be equal to u squared over 2g. And then we are using the y direction, so it's u squared sine squared theta over g over 2g. So this is going to be 30 squared so it's going to be 30 squared sine squared 42 over 2 times 9.8. This should give you the 21 meters that we have over there. And then lastly, the horizontal distance traveled. The horizontal distance traveled is equal to the range. So remember I said the range is now in the x direction, so it will be u cos theta times t. So this is 30 cos 42 times the time 4.1. This will give you the 91 meters that you have over there. Okay. Okay, so that's it. Right. Before I end this video, I'd like to show you some other tips on projectile motion. You may have something which is thrown from a cliff. Okay. So they launch from a cliff at that angle, theta. So it reaches a maximum height and then goes to the ground or to the sea. This could be the sea. So I want to tell you that it will reach a maximum height there where v is equal to 0 again at maximum height, and then at this moment there, which is level with the point of launch, provided there's no air resistance, the speed is equal to at the launch over there. It still has two components, the vertical and the horizontal, which will be the same as what we started off with there. Then we take that as our initial velocity now going down. Then this becomes our final velocity using the equations of motion. V is equal to u plus at. Then we can also have another trajectory whereby it's only given a horizontal velocity u. So in that case, we only have ux, and our initial velocity in the y direction is 0. So uy will be equal to 0. Then we start accumulating the uy as you go down. So by the time you reach there, uy will be equal to a maximum. So these are the scenarios. So it's just like the one that we had when we started, this one, but we are starting from this other half, the way we have an initial horizontal, and then the vertical is slowly growing until you get to the end. So it's just half this one that we started off with. Right, so I think I do not want to make the video too long so that you understand. Now please let me know if you have got any questions in the comment section, and remember to like and share and subscribe to the channel, Physics Tips for Cambridge Students. Signing out.